G'day, I'm Cameron, and today in our first episode of How to Make Stuff with Cameron, I'm going to be teaching you some basic techniques on how to join various construction materials using glues, screws and fasteners. I'm also going to go into Mig Welding a bit, teach you how to do that. I'm also going to cover some metalworking tools, and I'm going to be building a welding trolley as well. So hopefully you find this helpful, and hopefully you enjoy it as well. Okay, what we've got here is a range of fasteners that you'll most likely come across when making things. Now I know that most of you will probably already know what all of these are, but I'm going to tell you for those who don't. Now, starting over this side, we've got our wall plugs. Now, basically how these work is you have your concrete wall, you drill a hole in it with a masonry bit. Don't try and use a normal drill bit, it'll destroy the drill bit. You also want to have your drill and hammer setting. Basically how they work is you get a nice tight hole, you push these in, and then you get like a screw that fits nicely within the length of it, and you then screw it in. Now, the act of the screw going in will tighten the actual wall plug out onto the concrete around it, and you'll be able to hang something or mount something off the wall. So it's very useful in that situation. Now below that we've got our washers. Now these aren't specifically a fastener, they're really more for spacing and providing a bit more of an even load on things. Like say if we're using this one on a bit of sheet metal. Now what it does is instead of all the load being just on the bolt head, it spreads the load out and makes it less likely that you're going to tear out whatever it is. If there's being a force applied, it makes it a lot more durable. Carrying on from here, up here we basically got all our things that are better suited to working with steels, or steels and metals. Now these two here are bolts, obviously. Good thing to know with threaded stuff is if you ever get stuck, they always think lefty loosey, righty tighty, because 90% of the threads you'll come across are going to be work the same way. Now these two here are self-tapping metal screws. Now you can get a whole range of self-tapping metal screws. They're predominantly used for sheet metal. Like you can get ones that are made for a little bit thicker, but most of them you'll come across for sheet metal. If you're doing anything that's going to be a bit thicker than a sheet metal, you're probably going to want to pre-drill that hole, because the little drill bits are not very good and they'll often struggle to get through it. These two here are pot rivets. Now basically how a pot rivet works is it's got this little aluminium shell, and there's a metal tube inside it with a little ball on the end. Now basically this, the pot rivet gun itself basically grips the metal shaft, pushes against this little mini washer thing at the end. Now what it does is as it pulls this metal ball, pulls this shaft down, the metal ball compresses the aluminium cylinder around it, and basically it gets to a point where it becomes too much pressure and the ball will snap off. Now basically what happens is it sort of, because it's squashed it onto it, it sort of forms its own kind of fastener by compression. Now they work quite good, but then they're not really that popular anymore, just because there's other various ways. But I still quite like them. Coming down to the bottom side now, we got our normal, we got our various screws here, like of different sizes. I don't know if I mentioned before, but all these things come in a huge range of configurations. So you'll be able to find whatever one you're after in whatever size and thread pattern and a whole range of other things. But these are some of the ones you can get. So these are your screws. These two here are nails, and these two here are nail gun nails. Now these ones will fit in a standard C1 nailer. They've got a specific kind of nail, and so hopefully you find this helpful. Okay, what we got here is a range of glues and sealants that you can use to make stuff. Now glues are generally a very good cheap way to join things. They're very strong and they're very cost effective. Starting at the bottom here, we've got our two-part epoxy, commonly known as Araldite. They all work the same way. They normally have either a 5-minute set or a 24-hour set. Basically the 24-hour one is stronger, but it just obviously takes longer. How they operate is you basically squeeze out the two liquids, you mix them together until they've got a nice even mixture and they've changed colour, like it'll go like a milky colour, and then you can apply it. With the super glue, everyone's heard of super glue. It's very, very runny kind of glue, so it will get everywhere. I advise wearing gloves with these two especially, just because when they get on your hands they're particularly difficult to get off, especially super glue. PVA glue is just for wood. Now you want to definitely clamp PVA glue, or I always use nails or screws when using PVA glue as well. Unless I'm doing like dowel joints, in that case I just have it clamped and it'll hold itself. Moving along, this is PVC cement.
Now, I don't have a primer with it. Often you, to get extra strength with it, you will use a PVC primer. It comes in a similar sized bottle, and once you apply it, it changes the colour of the PVC to like a dark red. Now, that gives you maximum strength, but you can use it just as is, and it'll still be very strong. Moving up to the top here, this is our basically contact adhesive. Now, all it is a spray-on glue. It's, you know, it works pretty well. I've used it to install keyhole carpet down in the back of my car when I did the boot. It works quite well for that. It also works very well for putting laminates and stuff like that down. As you can see on the front, that's what he's doing. Moving along, now this is liquid nails. Now, a few people would have heard of liquid nails. It's a construction adhesive. It works with metal, concrete, wood, you know, all your MDF, all those other things like that, plastics. Very, very strong. You know, it dries relatively quickly. It's just, you don't have to mix it, it's set by air. I highly recommend it. It's a little bit pricey, but worth it if you want the strength. Going to a sort of a cheaper option, this one here is the All Fix. I don't really like All Fix very much personally, that's why I haven't opened this one actually, because I had another tube of it. I didn't find like it sticks to everything, but it's not particularly strong. So that's why I don't particularly like to use it too much, but you know, it is good for certain jobs. Moving along. This is the hot glue gun. Now, the hot glue gun, along with the All Fix, liquid nails, and these two here, will stick to virtually anything. The hot glue gun is not particularly strong when it comes to like your larger things, like whether it be wood, metal, concrete. It will still stick to them, but for stronger stuff, you don't want to use it. It's better for materials, rubbers, plastics, light duty kind of stuff, where you sort of just want to basically form a solid, you know, object that sort of can hold on to things. It basically works very similar to a 3D printer extruder. You have your cartridge that goes in the back here. It's a little cylinder or a tube of like a plasticky kind of material, and basically this end here heats up and it'll extrude it as you squeeze this trigger. But yeah, so hopefully you find that helpful. Okay, one thing I didn't cover before was how to actually apply these glues. Now, the other one, the All Fix, is in the same size cartridge. You can also get the sausages, which have a slightly different gun. This one here is a standard corking gun. How you load these is basically you put the end first, and you use this little lever here, which basically allows this to slide forward. Now, to make it basically extrude glue, you just pump this handle a few times. Okay, now I've actually built the welding trolley, but I'm going to show you how I designed it because I wasn't happy with the first take. Now, basically all I did is I took into account the length of the welder and the width, and I added on the amount that I wanted for the gas bottle holders, plus a little bit extra because I do want because the hoses do come from both gas bottles, and it's sort of, you need a little bit of extra just to stop them kinking. I also added a little bit extra on this side, as you can see there, so that it'll brace the door that comes down, and also so it's sort of level with the toolbox. Now, I would normally CAD design when I'm building something, but because it's such a simple design, it's literally some metal rectangle with a rectangle of wood on top of it with some caster wheels. So yeah, I didn't have to do that. All I did was just drew it out on paper, figured out the measurements in my head, with the tape measure and whatnot, and yeah, just applied it in real life, which honestly is how I normally build stuff, because CAD design, it does take a while, so unless it's really complex, you don't want to have to bother sometimes. Okay, now I've finally got this nice and square by tapping and wiggling a little bit to make sure it finally fits. I've got it held still with the magnet. Now I'm going to tack these sides and get a full square, or rectangle. There we have the beginnings of the base of our frame. Okay, now we're just going to finish off the welds. Okay, here we have a range of tools to shape and cut metal. First we're going to start off with the angle grinder. This one here is a 5-inch angle grinder. You can get them in a whole range of sizes and with a whole range of different discs. This is a cut-off wheel. This one here is a grinding wheel. You can get flappy paddles and wire wheels as well. This here is a straight electric die grinder. It's very good. It has a tungsten carbide tip. They work awesome. They're great for shaping stuff and getting into holes and making them a bit bigger. This one here is a propane blowtorch. It's great for heating metal. You can get it up to almost white hot, but it's not, unfortunately it's no oxy torch. Now these two here are just hand files. They're good for just removing a bit of material, maybe a bit of burr or whatever it is. This thing here is a drill powered nibbler. Now basically how it works is a small pin goes in and out like this, in between these sort of two little sort of like the jaws like that, and that basically will just punch the metal out through that little hole at the bottom. This here is an air powered version of this. It's just a normal die grinder. This here is a air powered body saw. It basically works like a jigsaw but just powered by air. It's very good for, you know, sharp turns and unusual angles. These two here are hammers. They're very good for working with metal. Just this one here is a ball peen. I'm not too sure the actual proper name of this one, but both of these are very good. They're probably my favourites, just for you know, whether it be panel beating or shaping something out of metal. These three here are also very useful. These are tin snips. Now you always get you'll get a left hand, a right hand, and a straight with tin snips. You can see by the way they cut which way it goes. This here is good for, you know, removing dents and, you know, shaping things. It comes with a variety of tips. It's a pneumatic hammer. You can even mount it and things and do other stuff with it. These ones here I should have mentioned before are drill bits. Now they can do wood, metal, plastic. They'll do a whole range of things. These particular ones are very good. I like them a lot. But yeah, these aren't all metalworking tools you can will come across. We'll talk about welding later on, but this is just some of the stuff I wanted to show you. Okay, we're going to have a quick talk about MIG welding. Now, basically, MIG welding is the easiest kind of welding you're going to want to learn. It's just a form of arc welding. Now, basically, what you need to do to make a MIG welder work is you've got to have a good connection between this earth clamp and the welding gun itself. Now, that requires you to grind the rust or paint or whatever it is off the steel you want to weld. Now you want to have one bit clamped to here, well this clamped to that, and where you want to weld you want to have that area nice and clean as well. Now basically most welders you'll get will come with either a factory manual, or my one in particular has the settings on the inside of the actual casing. So you want to go by the thickness of the steel and then follow the manufacturer's instructions. Now all these things are adjustable up here, but we'll get more to the point. So basically this, what I've got it set up as now is gasless MIG wire. Now it's just flux coated wire, and now it runs through here, through this big rubber tube. Well, if it's got gas hooked up, which I have got a gas set up at the back as well, gas will run through here as well. So you get your current, your wire and your gas all coming through this one line here. All that's going through this one is the current that's coming from this one, so it just goes back into the machine. Now, some safety equipment you want to use for MIG welding. Importantly, T-boots, because you'll burn your feet. Now, you might have seen me earlier in the video not wearing these. That was dumb. Probably shouldn't have done that. But it was just tacking the stuff. Anyways, slightly off topic. The best way to mark steel for what do you call it, whenever you want to cut it or do things to it, is with a whiteout pen. Now, because it rubs away very easily with metho, but it'll stay there otherwise. Now, these are pretty useful as well. These are MIG welding pliers. Basically, they've got a little hammer attachment on both sides. They're spring loaded, so it's easy to use with gloves, and they've got a wire cutting bit as well, so very useful. Some more important bits of safety gear. We've got welding gloves here. I've got another kind just over here. These are my preferred kind just because they're give you a bit more dexterity, they're a bit thinner and more flexible. But these ones, when it comes to more heat, because they're quite thick and made of leather, they're very, very good like that. So if you want to do oxy welding, I recommend thicker stuff. But for MIG and TIG and all that stuff, you want to use thinner stuff because it gives you a bit more movement with the fingers. Now this here is a welding apron. Now it's good for not burning holes in your clothes and stuff. I like to wear that when I'm sitting down like in welding, so you know, you don't get holes in your pants, because that kind of sucks. Most important thing, probably out of all of these, is the welding helmet. Now, if you're blind like me, you can actually get this thing in the back called a cheater. It basically gives you 2 times magnification. That's why you probably see me standing very close so I can have a better look at things. But basically, this one here is an auto darkening helmet. They don't have to be auto darkening, but it does help because you don't have to, you know, change the little visor thing. But you can get them with adjustable sensitivity and darkness, which that's what I've got there. But yeah, no, it makes it a lot easier if you've got a better quality one. Okay, now I'm just, because I didn't really want to ruin my girlfriend's camera, basically what I'm going to do is use this area as a demo for the technique of holding the torch. Now you want to wear gloves obviously, but you know, I'm not welding, so I'm not going to bother. Now, one thing I like to do is I like to brace it either here, or wherever's comfortable. Hold it at a nice sort of nearly vertical and push forwards. Now you always want to have the tip nice and close to this, like say hypothetically we're going to weld there. You always want to sort of be going along like this. Now, if you're joining 2 surfaces, you want to give it a little weave. So basically think of it as a pattern like this. That's obviously very exaggerated, but you know, you get my drift. So you sort of going like this and pushing forward, because the gas comes forward and covers the actual metal that you're, you know, trying to weld. Now, that's very important for a good looking weld, and a, you know, weld that's not going to have holes and various other things in it. Now, there are other techniques on how to weld. Like you can do, like, you know, you can weld directly like this. You can even drag weld if you really want to. But the best technique I've found is holding it nice and close, bracing the handle, pushing forward, and weaving.
Okay, what I've got here is a bit of flat bar that I've run a bunch of beads on, just to give you a demonstration of what to do and what not to do when welding, and also how you can problem solve a bit. Basically, this here is a good weld. This is what you want your welds to be looking like. As you can see, it's got even penetration, except for this little middle bit, which I was a bit too quick on, through the material. It also looks nice and smooth. It's got, there's no, you can see on all the edges are sort of joined quite nicely to the parent material. This one here, I've had the wire speed up too high on purpose, and also I may have moved along a little bit too quickly, because it appears that there's actually been a lack of shielding gas. See these bubbles? That's what that normally means. But also it hasn't penetrated very well at all, even though I've sort of, because the wire's been coming in too quickly, it hasn't had enough time to heat the actual material that's welded as well. Now this one here is a weld where the gas has been turned off completely. Now, the gas I've been using for this is a mixture of argon and CO2. You can just use plain argon, but it's a bit more expensive. But as you can see, it hasn't penetrated very well either, and it looks terrible. What happens with the bubbles is because the molten iron, molten steel is exposed to the oxygen, it tends to form lots of air pockets and stuff, and it's a very weak weld. Now this one here is the amps too low. Now as you can see, it's a very ugly weld. It's sitting basically on top of it like a poo, and it hasn't penetrated really at all. Now this could honestly be chipped off with a hammer if I wanted to, but I'm leaving it there just to show you. Now, this one here is with the amps too high. Now as you can see, it's sunk down into the metal a lot. It's very, very thin, and it's also, as you can see, there's a lot of heat distortion around it. Now this is okay on mild steel, because it doesn't really warp too much, but if you were doing this on stainless steel, this would be a very big problem, because stainless steel warps very badly and it's not what you want. But you could honestly use this weld, but you want to have it set a bit more like the first one, because this is sinking in too deep. This one here, other than where I've missed, unfortunately, this is with the wire speed too slow. Now it sort of actually hasn't it hasn't really penetrated very well at all. But it's sitting on it. It just hasn't become a very good weld, to be honest with you. It hasn't really sort of bonded with the material very well, and it hasn't penetrated deeply enough. So you want to have the settings corrected. So this one over here is just another good weld. So you want them to look like that.
When you're grinding, it's very loud. You definitely want to use ear protection, otherwise you will start going deaf very quickly. You also want to get eye protection, because I've had many pieces of steel in my eye, and I can guarantee you it is not fun. Okay, now I've got to grind all the shit off the top, making the nice and flush, so I can put on the wheels. we're going to put these wheels on. Okay, now I've cut this to size so it's fitting perfectly over the trolley. Now all I have to do is to put in these self-tapping metal screws. Now you want to make sure you've got a nice liberal coating of PVA all over the glue. What you do then, you put it down nicely, give it a little wiggle around to give it a nice even coverage. I also then like to wipe away the excess just because it looks kind of ugly. Just put that on the floor. Then take your nail gun. I probably should have done this earlier, but I did it to show you how it's done. We'll whack it in like that. Make sure that it's lined up perfectly. Now I'm happy with how that's sitting. So what I'll do, just check. And you're done. Okay, now I've finished doing the back one as well. So now we've got all this extra space to mount my gas bottle holders. Now I've got this one here, the big one, which I don't really use too often, but it's good to have both. And I'm going to put this smaller set here so I can have rented gas bottles and the ones you can buy. Now we're going to pop rivet the bottom bracket. Now this is the back end of a pop rivet. Now as you can see, it sticks out quite a fair way, so what we're going to do is smash the crap out of it with a hammer so it gets a bit flatter. Okay, I finished hitting the two pop rivets with the hammer and they're both considerably flatter. I highly recommend doing this just for the reason that it tightens them up quite a lot as well. Okay, now we're just going to screw this on. It's nice and steady. Okay, to do a job properly you should always give it a paint job at the end. What I've done is I pulled the metal frame apart and given it a coat in silver gal. Then what I did is I went over the whole thing in some cherry red. And here we have our finished product of our custom welding trolley. So hopefully you enjoyed our first episode of how to make stuff with a Cameron. Next time we're going to be making a lizard terrarium for my pet bearded dragon Jub Jub. Other than that, we're going to be covering some woodworking joints like dowel joints and shoulder joints. We're going to cover some other tools and some other hopefully useful stuff for you. If you enjoyed, please like and subscribe, and I'll see you next time.